Yesterday, I showed you this. Kick in a box. Okay? Today, I want I want what happens after you kick it. So I've kicked it and now it's like sliding. Okay? I want the free body diagram of that. Hi.
No, I know, but
Mr. Smiley.
Nice to meet you.
Nice to meet you. Are you?
I'm JC.
JC. So coming from Carlson. Okay. 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 Well, I need to get yours too. Okay. Okay. Free body diagram.
Yeah.
I am. Name, email, please. I want a box sliding after I kicked it. That. What forces are acting on the box during that period of time? Everybody got something? Thank you. All right, ready? Friction. And that's it. What? What about this force? Like what's the thing that's keeping it moving? What force is causing that? Okay. Once it leaves my foot, I no longer exert a force on it. I'm not a Jedi. Does that make sense? Once it loses contact, no more force. So what is it, pray tell, that is making that move to the right? Nobody? Good guess, no. Good guess, no. What's making it move this way? What makes it continue to move that way? And there it is. The inertia. Okay? Gotta be confident. Okay. And inertia is not a force. Okay? This is a very popular misconception to say there's a force going in the direction of motion. No. Let me take you blow by blow on this one. Initially, the box's inertia is at rest, wants to stay at rest. Okay? It's initially at rest and wants to stay at rest. As I exert a force on it, It's like, "Ah, don't like that. I want to stay at rest." But once it's moving, it's like, okay, let's just keep doing what we're doing. And once, if there was no force of friction, forever gone. Constant velocity, straight line path. Does that make sense? So the only thing acting on it is the force of friction. How are we doing with that idea? That is a very deep-seated misconception that I need to break. Okay, the reason why it keeps moving is because inertia wants to. You put it in motion and it wants to stay moving. Good with that? Okay. All right. So next step, pick the positive direction. Make the way it's moving positive. Okay. Step 3. Ask yourself, is the sum of the forces equal to 0? Talk to your neighbor and tell them why you think so. Why or not?
I was asking if we were saying the same thing. We were. And I know it takes you there. I got
Okay, what do you say? I got a solitary no. Is what do you say? Is sum of the forces equal to 0 or not? Why not? Inertia's not happy. How do you know inertia's not happy? What told you inertia's not happy? Close. What would this do if inertia was happy? Continue moving how? At a constant velocity. Did the box continue moving at a constant velocity? No. What did it do motion-wise? Slowed down. And eventually stopped. You okay with that? Sorry, multitasking. It's not my strong suit. Ooh. Okay. Okay, so not equal to 0. So next step is take an inventory of all the forces acting on the box. Add them together. Keeping in mind direction. Friction. Negative direction. Plus 0. I don't know. No other forces. That's it. Okay. So if it's not equal to 0, what do we set it up equal to? Mass times acceleration. Okay. Here's why again. I don't expect you to write all this out. We've just determined not equal to 0. So it has to be equal to something. We don't know what that something is. So it's the total force, the net force. But from Newton's second law, oh goodness. From Newton's second law, we know that the net force is equal to mass times acceleration. So I'm going to substitute that in here. So you can just straight away write this. Okay, good with that? And that's your setup. Okay, any questions there? Next question. Tell your neighbor. Tell them why. So we didn't take the test that they took like last week over Unit 1, which is over velocity and displacement. I will send you the review worksheet and the answer key. Okay, so you can have an idea what it's over. And then Thursday, is that a realistic?
Yeah.
Okay. Sound good? Okay.
But the net force is 0, then it's at a constant speed just because of like.
All right, what do you say? Are we good with beautiful butterflies? Okay. If you are moving at a constant speed, a straight line path, you have constant velocity, you're doing what inertia wants to do, net force has to be 0. Okay, I want you to set this up completely. Like, I'll give you a minute head start. Go. You were here yesterday, right? Mm-hmm. Yeah. I would highly recommend watching the video. I mean, figure out what you can. But, yeah, yesterday was kind of an important day. So, all right. Oh, that's fine. Yes, I see the potential. Thank you, sir. I want you to do all 5 steps, not just a free body diagram. Like, set it up all the way. Okay, let's see how we did. So the wind is applied force to the right. You have water resistance, drag, friction to the left. And make the way it's moving positive. Tell your neighbor. Why or why not?
It's just like, yeah. Is it going that way? Quite happy, maybe. I mean,
The sailboat?
yeah.
The sailboat's moving this way. So it's like,
Oh, I see.
does that make sense? Like, it's like if you're in a, it's like a leaf being blown on a windy day. Like it's, the wind's moving it. So it's not air resistance. We're going to call it applied force. Does that make sense? Okay, what do you say? Thumbs up, yes, equals 0. Thumbs down does not equal 0. What do you say? Sum of the forces equals 0. Why does it equal 0? How do you know? Constant velocity. That is how you know. Okay? Inertia is doing what it wants to do. It wants to move at a constant speed in a straight line path. Okay? So, you have applied force minus friction is equal to 0. That's your setup. Okay? Good with that? That's what you're doing tonight on homework. Okay? Doing the setup. Towards the end, I start throwing numbers at you. Do the setup first. Always do the setup first before you start plugging numbers in. Okay? All right. Today, we've got a lab. Do it. Okay. Um, yeah, I don't know. I like it. I feel like it. You should be because you're on my attendance. Yeah, they should be linked, and I don't know why they're not. I mean, I don't know who you. Oh, to get the. Yeah, I'll email that to you. Put your email on that. Just say what?
For the other one.
Let's do this one because this is gonna be a different location.
Oh, did we turn those labs in? It's just like done.
Oh, lab quiz coming.
Oh.
Yes. Nope. You're good. All right. So this is a favorite lab. Like this is like one of those highlight labs. Like, hey man, I remember in physics. This is one of those. All right. So this is a skateboard lab. Okay. First off, of utmost importance, notice the posture of the rider. Notice the posture that the rider is not in. Okay? I do not care if you are the spawn of Tony Hawk. I do not care if you got this sick ollie that you want to show me. Like, I've seen plenty of them. Like, that's cool. I am impressed. But you are not to ride on the skateboard other than sitting down. Okay? Good with that? Like, all right. So the rider, that's your job, just to sit, survive. It's kind of like tubing. Like you're along for the ride. Try to like you're steering also, so like try to stay in a straight line path. But that's what you're doing. Now, hang on to the rope. Okay. The force giver. Your job is the most important of this whole lab. Okay, this lab is a qualitative lab, meaning you're not really taking measurements per se, kind of like the bowling ball bump. Okay, you're just observing. Okay, it is of utmost importance that you pull with a constant force. The spring scale that you'll be holding will tell you you must keep that needle at that location the entire time. Okay? Has to be constant. If you don't pull it constant, you're going to fail the lab. You're going to miss the whole point of the lab. Okay? You're going to have to pull with a constant force. Now, I've seen people cheat trying to like keep the needle the same. So we're not using these honking things, but let's pretend you were. And there's a rope coming off the end of this. Pretend there's a rope, okay? You're supposed to pull it like this. I've seen people try to cheat by pulling the rope. I got it. You can stand there and do that, okay? You need to apply that force to the rider, okay? I've also seen people try to jam their thumb to keep the needle at 65. That's like super gluing your speedometer. Officer, I swear, I was just going 55. Like, that's what my speedometer says. Like, okay, does that make sense? So, like, you must move to keep that needle constantly. Now, here is a popular wrong way to start this. Well, first off, this is a good way. Nope, I'll tell you a bad way first. Starting like this, just start trying to pull. You need to like establish 65 newtons. So rider, put the brakes on. Okay, wait until they get 65 newtons established on the spring scale. When they're like, yep, got it, then pick your feet up. Okay. Force giver. Resist the temptation when we say go to like that's just in you. Like go, ooh, gotta go. Like just focus on that needle at 65. Okay, good with that. The other person in your group, you're the catcher. Okay, you're providing the safety net. Okay, good with that.